In this tutorial, we will be converting Dicoms to PNGs. We're going to use this batch of scripts to do this, so download them to your computer, and then go to the folder where your Dicoms are stored, and you want to extract the scripts into the same folder as the Dicoms. So we will be using this DCM to ASC first, and then ASC to PNG second. So first we'll need a program called xmedcon. This will let us read the data in Dicom images. So sudo apt-get install xmedcon. Now that that's downloaded, you will also need Python 3. I already have this installed, so I'm not going to install it here. And to run our first script, do /dcm to asc.sh. This will take a little while as it sorts the images spatially and converts them to an ASCII file. Okay, so now this ASC folder will be populated with ASCII files. So what this looks like is it has a bunch of zeros here where the image wasn't taken, that black spot in the corners, and then you have these lower values representing the air above the patient, and higher values where the beams are actually going through the patient. So we're now going to be using this ASC to PNG8 to convert these ASCII files to 8-bit PNGs. But first, let's look at the output from the script we just ran. You'll see that it didn't find any units specified, which in Dicom standards means they're in HU, so that's good. The slope is the final value in brackets, so if you see that, that's a 1, that's good. And the intercept is -1024, that's also good. In the Python file, we also have this slope and intercept, and if the values were different, we would need to change them. But if you remember, it was 1 and -1024, which is what we already have. We can also set the windowing level. This is the high point and low point, sort of in HU, but instead of air being -1000, air is 0 here. So just add 1000 to whatever your value is and put it here. We're going to pretend like we're converting this image to be used with Windows in the CT viewer, so we're going to use the range 0 to 2000. Now run the script by typing Python 3 asc to png8.py, and this will take those ASCII files from the ASCII folder and it will turn them into PNGs in the PNG8 folder. This will take a little while. Once it's finished, it will output some stats about the files you just converted. So it tells us that the highest value was 4071, which is way above our value of 2000. And although this seems bad, it's really not that bad. The percent of values actually captured in our window here is about 64, which again seems low, but if we look at the percent actually above the window, we can see that it was only 0.1%. So the values from 2000 to 4071 were actually only 0.1% of all of the values. And we can see the values below the window was 35%, but if you remember, our low point was 0. Nothing should really be lower than that. So anything lower than that was actually air. So it was all those zeros in the corner of the image and the little bits of air above the patient. So really, we captured almost all of the values in the Dicom. Now we can go to the PNG8 folder and see our images, and it looks like they were sorted correctly, so we're done.